All right, welcome to the next section, section 3.3, logarithmic properties. This should be a review from Algebra 2. I know logs are pretty tough, so that's why we do it again in PreCalc. So what are the properties of logarithms and how do we use them is basically what this section is about. And what we're going to learn, how to apply the properties of logs and apply the change of base formula. Change of base formula is really, really easy. All right, so let's recall. Okay, we used to have some exponent properties. Okay, and what were these exponent properties? The product property said if you have the same base multiplied with exponents that you add your exponents together. Okay, that was the product property. So if you have the same base raised to exponents, you add your exponents together. The quotient property said that if you have the same base with a division problem, that you subtract the exponents. You do the top minus the bottom. And then we had the third one, which was called the power property, that said if you have an exponent raised to another exponent, that you multiply those exponents, x times y. And that's how you come up with your answers. So now we're going to relate these properties to the new log properties. And let's recall from the last section that logs and exponents, are inverses of each other. Okay, so what that means is that if exponents have certain properties, logs will have very similar properties because inverses they have a relationship, they're attached. Okay, so what is the product property for logs? Okay, it says that if you have a log with any base and you have two things that are being multiplied, okay, the product property in the last one says that you add them together. Same thing with logs. You can split these up and do log base b of x plus log base b of y. So you can separate the x plus y with a plus sign. Okay, the quotient property. What did the quotient property say for exponents? You subtract your exponents. Well, quotient property is the same for logs. So if you have a log base b with an x divided by y, the property says that you subtract them, just like we did for exponents. Log base b of x minus log base b of y. So you subtract the top log minus the bottom log. And then we have this power property, which is very similar. Okay, what did that say? That says you multiply your exponents. Okay, it's not quite as similar as that, but it is pretty close. So if you have log base b of x to the y, so y is the exponent now, the property says that you can take the exponent and you can put it in the front and multiply. So it would turn into y times log base b of x. Okay, so it is similar. The power property, you do multiply. Okay, and these go back and forth. Okay, they go two directions. You can go back and forth. So if you have something like the right, you can make it look like the left. Okay, so let's do some examples. Okay, now in all of these examples, you're going to see there's an A and a B. We're going to do one of the two together, and then you can try the other one, or we will also do it in class the following day. Okay, so example 1. It says express each log in terms of ln of 2 and ln of 3. Okay, so we're going to use the numbers that they give us to try to use ln of 2 and ln of 3. And at the same time, we're going to try using our property that we just learned. All right, so let's do B. We'll save A for later. It says ln of n divided by 8. Well, what does divide mean? Quotient means you can subtract the top minus the bottom. So that's what we'll start off with. So ln of 9 minus ln of 8. And then we're going to see how can I use 2 and 3 to get 9 and 8. Okay, so I can get 9 by doing 3 squared, and I can get 8 by doing 2 cubed. Okay, so then what does the property say that I can do here? All right, so the property says that if you have an exponent, it comes to the front. So I have 2 ln of 3 minus the 3 goes to the front minus 3 ln of 2. So I've turned ln of 9 over 8 into ln of 2 and ln of 3. That's just what the directions told us to do. Okay, so we are going to save part A for later. That is the answer to part B. All right, example 2. It says evaluate each expression. All right, so let's do A this time. A is a little bit tougher than B. We'll save B. All right, it says evaluate each expression. Okay, so we're going to see what we can do here. So first thing I'm going to do is I'm going to turn this fifth root into 64 to the 1/5 because I need to be able to work with these numbers. I can't work with them when they're underneath radicals. Okay, so it's 64 to the 1/5. Now, I know a property from the last section that if I have a base 4 and the number next to it's also 4, that will cancel out. Okay, so what I'm going to do is I'm going to turn 64 into 4 to the third power. Okay, turn into 4 to the third. So now we see we're getting somewhere. So now I have a power to a power. I'm going to multiply my two exponents. So I have a log base 4 of 4 to the 3 times 1/5 is 3/5. Okay. Now I'm going to apply my product property. So it says if your log has an exponent, it can come to the front. So I have 3/5 multiplied by log base 4 of 4. And from last section, we know that log base 4 of 4 is equal to 1, so it just cancels, and I'm left with an answer of 3/5. Okay, so that was pretty tough. That's a tough problem to do. So we basically are using our exponent properties and our log properties to simplify logs. Okay, so that's able to be tomorrow. Okay, example 3. Okay, now we're going to use our properties to expand, make them bigger, what our logs are. Okay, so we're gonna look at what we have here. We're gonna try to make it bigger by using our properties. Notice that all of these things are next to each other. That means multiply. Okay, so if we go back to our properties, the product property says if you have a bunch of things being multiplied, you can add them together. Okay, so that's what we're gonna do. We're gonna separate them by addition. So we're gonna do log of 12. That's our first number, plus log of x to the 5th. That's our second number, plus log of y to the -2. Okay, so we've made it bigger more, but now notice that we have exponents. What does the exponent property say, or the power property? It says that if you have an exponent, it comes to the front of your log, so that will expand it even more. It's going to make it wider. So log of 12, nothing to do there. We're just going to leave it. Plus the 5 is going to go to the front, so 5 log of x. And then we have a -2 exponent that's going to come to the front. So you could put plus -2. I just do a -2 log of y. Nothing else we can do. This is fully expanded. We are going to stop. Okay, that's called expanding each expression. Okay, you can try number 2, or we will do number 2 together, or part B. Okay, example 4 now. Example 4 says that we are going to condense. Condense means make smaller. So if you want to make smaller, please do. And on the last example, you might want to say expand means to make larger. Okay, we're going to make that one larger. Expand means make larger. Condense means make smaller. Okay, so let's do, let's do part B this time. Okay, so what do we notice? We have a plus, so that's probably going to mean multiply. And we have some numbers in the front, and those are going to be our exponents on each of our terms. Okay, so let's see what we have here. So let's do the exponents first. So I have ln of x minus 4 to the 6th power plus ln of x, and the 3 goes to the exponent on the x. Okay, so that's step 1. We've turned our exponents into exponents. Now we have this plus sign that we can deal, so that means we can combine both of these together. So if we go back to our properties, remember these go both directions. So if I see a plus, I can turn those pluses into just multiplication. Okay, so we're going to turn this plus into multiplication. So we have ln, and then we are going to multiply these two together. So x minus 4 to the 6th times x to the 3rd. And we've fully condensed this problem. We took this long drawn out thing and we turned it into something that's much smaller, much more condensed. Okay, so those are the 4 examples based on using log properties. The last one is super simple. Basically what this change of base formula does, it helps solve any log on the calculator. Okay, so how does this work? Okay, so I wrote it big so we can work with this. It says have any log, but with base be any x. So let's just make one up. Let's do log base 6 of 7. Okay, how do you do this on a calculator? Well, remember, calculator only does log base 10 or just regular log. That's all the calculator will do. Well, this is log base 6. Calculator won't do that for us. So this change of base formula helps us do this. So basically what you do is you take log of the x. So our x is 7, so log of 7, and you divide that by the log of the base. Our log of our base is 6. And you just divide those on your calculator and you come up with your answer. So for our answer, so since calculator, this log means log base 10, we're going to do log of 7 divided by log of 6. And the answer to that log is 1.09 equals 1.09. Change of base is super simple. Okay, let's do one example. It doesn't matter. Let's do part B. So to solve this problem, let's think about what this means again. So let's apply the definition. 1/2 raised to what is equal to 6? Well, to be honest, I have no idea. I'm sure most of you have no idea either. So what we're going to do is we're going to apply the change of base, okay, which says you take log of the x, which for this problem is 6, and we're going to divide that by log of the base, which is 1/2, and we're going to see what we get. So clear this out. So log of 6 divided by log of our base, which is, you could do 1 divided by 2, or you could just do 0.5, and this answer is negative 2.5 something. What did that say? Negative 2.58. Okay, so 1/2 raised to negative 2.58 is equal to 6. Well, I'm assuming nobody could possibly figure that out in their head, so the change of base formula helps us do so. Okay, so we'll do part A tomorrow. All right, so that's it. That's how to use the log properties. They're pretty tough, I know, but we will discuss these more tomorrow.